to Deeksha Vedantu. I'm your Tanvi Mam, and today in this video we are going to quickly revise all the methods of separation of the mixtures we have studied in the chapter exploring mixtures and their separation. So we are going to dive down into all the methods that we use to separate those mixtures. Now beta, remember this video is very important, so make sure you watch it till the end and you pay attention throughout because this is a very important and new topic. Okay, now beta, this we talked about two kinds of mixtures, that is what homogeneous mixture and heterogeneous mixtures. Now homogeneous mixture is what bacha, is what it looks the same throughout, right? And heterogeneous mixture, it does not looks the same throughout. Homogeneous mixture, something can be sugar solution, salt solution. Heterogeneous solution mixtures can be your sand in your water, the chalk powder in your water. So all those mixtures are called heterogeneous. Now if you want to separate sand from water, you can quite easily do it with sedimentation or filtration, right? But can you separate milk with that method? No, you can't. Can you separate sugar with that method? A sugar solution, the soluble sugar from water with that method, with that we call it pony in Punjabi, but with that filter, right, we use in our houses to filter out the tea, right? So will you do that with the sugar solution? No, you won't. So we have different kind of methods of separation, right? For that, let's go with the homogeneous mixture first, and the very first bacha is crystallization. Now crystallization bacha is, from its name it's clear that we are going to talk about crystals. So what are crystals? It is a solid that is made up of particles arranged in a regular geometric pattern. So our particles are arranged in a regular geometric pattern, whatever that pattern can be. That pattern can be this, that pattern can be like this, but they are arranged in a specific pattern. Those are called crystals. Now what is crystallization? Forming of these crystals. Forming of these crystals from a saturated solution. Now do you remember what a saturated solution is? Saturated solution is in which we cannot add more solute, right? It has reached its saturation. We cannot add more solute in that amount of solvent on that particular temperature. Understood? Now making of crystals using saturated solution in laboratory is called crystallization. Now what's the actual process of it beta? The actual process is very simple. Okay, two things that you need to remember. First, it is being done by using saturated solution, okay, and second, it is used to separate homogeneous mixture. These are the two things you have to remember. Now what we actually do, what we take copper sulfate solution, okay, and we try to burn that, we place it on a burner. Okay, see, this is a china dish, this is a copper sulfate solution, and we place it on a burner and we make it into a saturated solution. That means no more copper sulfate can be added into this solution. It starts to settle down. Okay, then we filter it, then we filter that solution. All the massive impurities, they gather around here, and this is our filter it. This is the pure substance. Because why do we use method of separations? To pure a substance, to get the purity, right? So this is your pure substance. Now you let it, you cover it with a watch glass, you let it cool down, and once you cool it down, these are this very pretty small bright blue color of copper crystals will be formed. They look so beautiful if you have seen ever in your labs. Okay, so this is the whole step by step. If you want a screenshot, you can get that. So this just basically explains it. Now one more thing is, you can also take salt and water and can perform it at your home as well. You have to add salt until the water is not accommodating more salt, right? The salt is trying to settle down. Until then you have to boil the mixture, keep the water heated, and keep adding salt. Once that is added, you filter it out, you keep the solution sideways, and bacha, you let it cool down for a night, and then your crystals will be formed. Now if you do it at your home, there is one important thing that you might miss, that is your addition of dilute sulfuric acid. So you don't do it at your home, you do it in your laboratory, in your school, right? And make sure you have your teacher with you to add this dilute sulfuric acid. It is very, very harmful, bacha. It can burn your skin as well. That's why we wear lab coats. right? So this is all about crystallization to form the crystals. Now there is one more thing you can do, that is evaporation. You already have a saturated solution, you heat it and you make sure that water or whatever your solvent is, it's getting evaporated, right? When the solvent is getting evaporated, see, this is a saturated solution. You cannot put more solute into that solvent, but if I keep the solvent, take the solvent away, that solute is more in that remaining amount of solvent, right? So I took like 50, there is 100 ml of water, 5 gram of salt. I took 50 ml of water away. So the 5 gram of salt, this was already a saturated solution, but it will be not a saturated solution now, right? The salt will be excess, it will start settle down. And if you keep it like this, if you filter it, let it cool down through the whole night, crystals will be formed. Okay, done with crystallization. Now bacha, next technique is this is a whole thing as a scientist, okay? So they are basically asking, what if you don't let these crystals to slow down to or cool down very slowly? What if you quickly place them in a refrigerator? That but not pure crystals, pure arrangement of crystals, their atoms won't be formed, very distorted and bad looking crystals will be formed, and we won't want that. Right now we said that in this crystallization I evaporated the water, or I took out the extra water, right? What if when I'm evaporating, what if I want to collect that water? That is where distillation comes in place. So beta, you have a water and acetone solution. Now you want to separate them. How will you do it? Dekho, water and acetone, they can be separated using distillation. Now what is distillation? See, we studied crystallization, right? So we evaporated and whatever left form crystals. Now what we do, we evaporate and we don't let it go out in the atmosphere. What we do, we collect it, and this is a condenser, water condenser. That is, water is running around the condenser, and inside that there is one more cylinder, right? And inside that something like this, okay, something like this. So here we have water and it's a long tube like this. So here we have water, here we have water, and inside that thing we have our solvent that we want to collect, right? So when you are heating something, right, when you are heating, it will vaporize and all the vapors will rise above. Now instead of them letting them go into the atmosphere, we collect them, we pass them through a water condenser, and what will happen if you like cool down the vapors? They will become liquid again, right? This will become liquid again, and this is connected in a separate conical flask. The other one is just kept there, right? Now you have, let's say, water and acetone. Now a very important thing about distillation beta, in both the mixtures, in both the substances that you want to separate, they should have at least a difference of 25 degrees Celsius in their boiling points, because we are boiling the solutions. That's why they are getting vaporized, right? We are boiling the solution, the substance which has lower boiling point. See, water and acetone. See, water has a boiling point of 100 degrees Celsius and acetone has a boiling point of 56 degrees Celsius. You start heating, you will reach 56 degrees Celsius faster, right? As you reach 56 degrees Celsius, acetone will start evaporating. And I'll keep the temperature at 60 degrees. So all the acetone will evaporate, but water boiling point is 100 degrees Celsius. So it's not boiling, only the acetone is boiling. So as the acetone is boiling, the vapors will go up and they will go from this, they liquidize again, and we connect acetone here. The water remains in this flask. Done. That is all the distillation we have. It's based on boiling point. The liquid with lower boiling point vaporizes first, we collect it in another flask, and these both solutions are now separated. Done. And they both should have a difference of 25 degrees Celsius temperature. Now ma'am, if I have to separate something, they don't have that much difference. There comes fractional distillation, and we use it in our industry. So there was so much fuss about crude oil, right? Why crude oil is important? Because beta, when we get crude oil, we get it in a furnace and we heat it, right? Now when it goes here and it's getting heated, let's say till here the temperature is only 50 degrees Celsius. So all the things evaporate except lubricating oil. what is the lubricating oil, right? So every other oil, every other substance, the crude oil is being made up of 6 or 7 oils, right? So all the oils evaporate and only the lubricating oil is left because its boiling point is a lot more, right? So it is collected in here, we liquefy it, distillation, we liquefy it and we use it. Then till here we goes to the second stage. Now again the temperature is a little bit more, okay? So the diesel, that everything else evaporates but the diesel does not evaporate, right? Because the boiling point of diesel is so much and boiling point of all other vapors is so less. So they all evaporate, the diesel remains, we collect it out. And same with aviation, here aviation remains, everything else evaporates out, and then we collect petrol and then we get petroleum gas. Done. That is what fractional distillation is. Now bacha, next we have paper chromatography. Have you done something like that? If you are giving an exam and you are so tired and you're writing so fast, you sometimes get sweat and your sweat drips on that paper and it does this to your ink, to your answers, right? So bacha, this is what we use in paper chromatography. Now what is paper chromatography? Very simple. You take a strip of paper and at the end you make a line and you place one ink spot, let's say black pen, okay? You mark the black pen, mark the ink very highly, so very much ink on that point, right? Now you have this, now you put that in water, but remember the water should be so less in the glass that it should be very low than the actual point. It should not touch this dot, this ink you have put of black pen, right? Now what will happen? Due to we know that this whole strip of paper will start getting wet. Water will start to travel upwards, right? So when it reaches this dot, the ink will also start traveling upwards. You know that, right? We have seen that somewhere. You can do it in the house very easily. The ink will also start traveling upwards, and hence if it reaches above and above, you will see the black pen is actually blue. It has actually blue color in it. So it is not just made up of black color, it is made up of blue color and other indigo colors and all that colors, right? Where do we actually use it? So bacha, we can also do this. See, there is a whole experiment. You take a spinach leaf, right? The extract of spinach leaf, you put it on a paper, put it a dot, just like the previous experiment. Now you dip it in a solvent. This solvent can be water, it can't be water, depends on whatever we are experimenting with, right? And as you see the water, the solvent will travel upwards, you will see all these different kind of colors. Now a very important thing in this is to remember the affinity of the substance, the affinity of this leaf or this pigment to travel towards the water or towards the paper. Now if this affinity means love, okay, so we talk about affection and all, right? It's almost the same thing. So this green pigment, right, this green pigment is made up of all these stuff, chlorophyll B, chlorophyll A, xanthophyll, keratin, right? Now all these stuff have different affinity, different love towards either the solvent or the paper. Now this chlorophyll B, it likes the paper a lot. It's like, I am affinitive towards the paper, I'll stay here, I won't go. And chlorophyll B is like, okay, I am going with the solvent above, so it goes above. And from this, xanthophyll says, I want to go more above, and this reaches, okay, no, now I love the paper, I want to stay here, and it goes above, and hence keratin has affinity with what? It has affinity with solvent, whereas this chlorophyll B has the affinity towards paper. Understood? Because it remained with paper and refused to go up with the solvent. However, keratin went up with the solvent and did not remain with the paper. Done? Okay. Now we are done with homogeneous mixture. Now beta, moving on to heterogeneous mixture or immiscible liquids. Now if you have put oil in water anytime, you will see that they do not like each other. They don't have affinity towards each other, so they won't mix. So how will we separate them? Ma'am, it's very easy, we know. Okay, we'll just take this flask. Okay, you can easily find it in your chemistry labs. Now there is this cork kind of stuff, so you tight it completely and there is a solution of water and oil. Now you know that whenever water and oil are mixed, the oil is lighter, so it goes up, the water is heavier, so it stays down. So there are two layers. The upper layer is of oil, the inner layer, lower layer is actually water, right? So when you open this, water will start coming down, oil will not come down. Water will start coming down and it's dripping and dripping, it's dripping, it's filling the container until when you reach here, when all the water, almost all the water is drained, only small water is left. But now if you open it, you might get the chance that oil might come out with it, right? So you just close it, you take this out, you get another beaker, you again open it a small, you can like open it very smallly that it's just one drop is coming out. Okay, so now what happens, as soon as one drop of oil comes out, you turn it back off. Okay, and then you discard this, the oil and water mixture one, and then you again open it, get another beaker, extract all the oil. Now you have two beakers, one in with we have pure water, the another with which we have only the oil. So we separated immiscible liquids, and similarly we can do with sand and water, iron fillings and sulfur, and all these are examples of heterogeneous mixtures. Done, bacha? Okay, next we have in this is sublimation. Now what is sublimation and why do we need it? Now sometimes I am very lazy and whatever, so I accidentally mixed camphor, the powdered camphor with sand, and your mother is like, get it separated as soon as possible. And you're like, I know sublimation, I will separate it like this. So what do? You go to your chemistry lab and you ask the help of your teacher, and you're like, I want to do sublimation. Now what is sublimation? What is sublimation, bacha? You keep that whole powder, sand and camphor mixed, you keep it in a conical flask, right? And then you heat it by placing it in an ice bath. Okay, now you are heating it, and what happens? Will sand evaporate? No. But what is the property of naphthalene or camphor? That it evaporates. It directly goes from solid to, it does not evaporate, it do what? It sublimes. It directly go from solid to gas, right? Solid to vapors. So that camphor, the vapors of this camphor will start accumulate on this, in the walls of this glass, and then you separate it, all the sand is there, all the camphor is on the walls of this container, and you have separated camphor and sand. Easy, very easy. Camphor on heating changes directly from solid state to vapor state without passing to the liquid state is called sublimation. Now what you will do, this camphor that is there deposited on the wall of the this flask, it condenses back. Once you stop the heating, it condenses back directly into the solid. It won't go into the liquid phase at all, and that is called deposition. Okay, it will deposit on the walls of the container. Done, and you can scrape it out. Okay, hence camphor sublimes and separates from sand, because sand does not sublime on heating. That we obviously know. Next, bacha, a very important thing, two very important things we have. That is your first, this is basically just the example of alloys. You know what alloys are, right? The mixture of two or more metals, non-metals is called alloy. How do we actually mix the metals? We heat them, we mix them together, and the final result, when they cool down, the arrangement of atoms is a bit difficult, bit different. That is your new element, not steel, not iron. It's just a mixture of all the thing, and you need to remember all these, not the compositions, but you need to remember the stainless steel as at least. Okay, so that is a mixture of iron and other elements which are carbon, molybdenum, chromium and nickel. Done. Now after that, bacha, very important technique, that is your suspension. Now suspension is again a very important technique. How, beta? Because there are some kind of solutions we studied about colloids, right? If there is milk, can you filter it out? Can you do distillation? Can you do sublimation? Can you do crystallization? No, you can't, right? Because the particles are somewhere between 1 nanometer to 1000 nanometer. So it's not a completely true solution, that is homogeneous solution, and it's not completely suspension, that is heterogeneous solution, right? Now it's somewhere in between. Done. So how to separate these two? So we have two options, centrifugation and coagulation, and this is the same technique that your mothers use almost every day to make paneer, to make cheese. right? So suspension are what? Heterogeneous mixture in which the solid particles do not dissolve but remain suspended throughout the bulk of the medium. So even if you separate sand from water, you will still see that the water has a weird color. It's not purified water, right? So how to separate that sand from the water now? Okay, that is your task. Now, bacha, because in this case of suspension, the particles of the undissolved substance are larger in size than the particles present in the solution. It's already what we studied. Now, how we did it is first centrifugation. You know this sport, it's called kikli in Hindi or Punjabi. So what we do, we rotate and we feel a push outwards. So that is the exact science we use in separating things, right? We rotate them, they feel, the heavier particles feel a push outwards and they separate at the bottom part, the other lighter part is in the middle of the test tube. So what we do, we add test tube, we add blood sample, let's say here. So whenever you add, this is a centrifuge. This is a machine in which you rotate the test tubes at a very high level. So what happens when you close it, these get horizontal, right? And they start rotating. They start rotating at a very high speed. And as they start rotating, that the blood sample will feel a push towards outwards, and all the WBC, RBC, they will feel a push outwards because they are heavier than plasma, the liquid, right? So they will separate and they will separate out at the bottom of the test tube, and all the liquidy part will remain on the in the middle of the test tube. Okay, so that is what this process involves, spinning a mixture in a tube at a high speed. During centrifugation, the tubes become horizontal, and the centrifugal force, we studied that in physics as well, right? The force on the body outwards when it rotates in a circular motion, so causes the heavier particles to move outwards, where they settle at the bottom of the tube while the lighter liquid remains at the top. Understood? The blood, such as RBCs and plasma, and in many chemical industries. Okay, that is what your centrifugation is, to separate out to separate out the heavier elements in a solution than in a mixture, okay, by rotating them at a very high speed horizontally. Then next, bacha, we have coagulation. What happens in coagulation? There is a thing called alum, right? Alum, or we also call it fitkadi. It's basically used in water purification. Okay, so what happens? How water gets purified? What happens? We put it in the water. What it does, it makes all the sand particles get scared that a boss came, right? And they all coagulate, they all come together, form a big group. Now they are heavy. Now gravity will attract them towards itself, right? So they settle down and water is pure. How do we? This is what we use to make cheese at home, or paneer. What do? We add lemon juice in the milk, right? The lemon juice acts as a coagulant. What it acts like a? It acts like a coagulant. This here, it acts like a coagulant. Why? Because it happens to have coagulation effect on the water, on the milk. That means all the particles, they come together. As soon as you put lemon, it's little heated, you put lemon, all the milk particles, they separate out, they come together, form big lumps, and they settle down, and upward you see almost not so much pure water. It will be a little milky, but you will see all the paneer has gotten out. You'll extract out the water, and there you get your amazing cheese that we eat a lot, that is very rich in protein, right? So, bacha, all these techniques are used for separating the mixtures, that is homogeneous mixture, heterogeneous mixture, and there are different types of techniques we used. Crystallization, distillation, then fractional distillation, paper chromatography, those are for homogeneous mixtures. For heterogeneous mixtures, beta, we use what? We use sublimation, we use coagulation, we use centrifugation, and did I forget something? What else we used? Yeah, that is it. Two immiscible liquids, that's the basic technique we used before that. That is it, bacha. We have done all the methods of separation. This is very important for your boards, for your class 9th examinations. It's a very important technique as well. You will see you are studying all this in your masters again if you take. Okay, so that is it for this video, bacha. I'll meet you in the next video. Hope that you're preparing, you're utilizing these vacations, all these days very in a better way. Okay, tata, bye bye. I'll meet you in the next one.